All right, welcome to another video in our node by node challenge where we're going through every single node in the shading workspace within Blender. And we are going through all the different ones in version 4.3. We've gone through all the inputs and outputs and colors, and we are on the converters. And we are on one of the longest, most complicated ones yet, which is called the math node. So we are going to be doing this in 3 different parts. This is the first part that we are going through for the math node, and I will be going through the first column of all the different options within the math node. So I am by no means an expert, so definitely make sure you do searching if you want to learn more about each of these individual ones, but I'm going to hopefully try to simplify some of the more obvious ones for you and explain the basics of some of the more complex ones. So first off, we've got a sphere over here on the left hand side. I created a new material that just has the principal BSDF and the material output. I added in a noise texture just to be able to show you how this works. So for example, if we plug in the noise texture to the base color and it's set for a scale of 5, this is what it looks like. Okay, and this is important to know what it looks like because as you go through these different math nodes, it's going to change the way it looks based on what kind of math we're doing. So, for example, let's say that we use this 5 as our base. So I just pulled in a value node so I could start it at 5. So we know that that's our starting point. And now we're going to have a math node for whatever we want to do. So add is really simple. All it's going to do is add whatever number that you have below here, which I put in a value of 2, and we're gonna plug this into the scale. And so now what it's going to do is it's going to take 5 plus 2 equals 7. So 7 is the scale. So if we go and we change this, all it's going to do is it's going to increase the number. If we change what the value is here, it's going to add more or less depending on what we change it to. Next one on here is subtract. So now, instead of adding 2, it's subtracting 2. So it's taking the value of 5, minusing 2, and so now the scale is 3. Okay, so pretty straightforward so far. Then we get into the next one, multiply. So now it's taking the 5, multiplying by 2, so now the scale is 10. So this is what it looks like as 10. If instead of having the multiply in there, you just move this to 10, roughly 10, it's going to look the same. So it gives you an idea of how that works. All it's doing is it's just doing what we calculated here. So 5 times 2 is 10. Now if we go to divide, it's going to take 5 divided by 2 is 2.5. So it's only showing 2.5, which has barely any noise. We go to the next one, we do multiply add. So all this is think of it as 2 separate steps. First, we're taking the 5, we're multiplying it by 2, which is 10, and then we're adding in a half, so that's 10.5. So this is what 10.5 would look like. Power. Power is taking whatever number we have to that exponential power. So, for example, 5 to the exponent of 2, all that is 5 times 5. So 5 times 5 is 25. This is what 25 would look like. If we change this to 3, that's now going to be 5 times 5 times 5, which now is 125, hence why it's all really small. Okay, so we don't need to go up that high, but just to give you an idea. And it just goes on from there. It would be 5 times 5 times 5 times 5, as many times as you put the power up here. Okay, next is you have the logarithm. Logarithm is the opposite of that. So, for example, if we put 25, it's going to say 25 divided by what is 5 to what power, and all that is 2. So hence why there's nothing here, because 5 times 5 equals 25. Now if we did 125, that's going to be 3. So no matter what number we put in here, it's going to be, and it doesn't have to be whole numbers. So let's say I put 5,000. Okay, it's 5 to what power equals 5,000. Okay, which obviously it's way higher, so it has you're not seeing anything at all. But no matter what you do, so 25, let's say we did 625. Okay, you're going to see it keeps changing it. And you can't really tell in the video, but it has a little bit less variation to it. So that's logarithm. It's what times this would equal the base. Okay, so next you got square root. So now all it's doing is it's taking the square root of whatever number we put in here. So in this case, the square root of 5 is what it's showing, hence why there's not a lot there. If we did 25 on here, you're going to see it being equivalent to like 5. 125 is going to be it's going to be the square root of 125. So it gives you an idea of how that works. Like 169 would be square root of 169. It's 13. So this is what 13 would look like. Okay, so we'll put this back to 5. Okay, next is inverse square root. Okay, so this is all this is doing is it's saying that we're going to take and do this, what is the square root, or what is this the square root of, and then do 1 divided by that number. So 5 is the square root of 25, and you do 1 divided by 25, which is 1/25. Hence why it's pretty much might as well be 0, because it's so low. So that's the inverse square root. Absolute means that no matter what this number is, it's going to be positive. So 5, as you see there, is the same as -5, because it gets rid of the negative symbol. All it's doing is saying that no matter if it's negative or positive, it's going to be the same number. Okay, so in this case, it would be 5. Okay, and then the last one is called exponent. Now, exponent is a very bizarre one. I personally never used it before. It's this thing called Euler's number, which basically all it means is that it is 2.718 to the power of whatever you have selected here. So, for example, anything to the power of 0 is just 1. So if this was a 0, okay, then this would be equivalent to 1, which is basically nothing. Now, this being a 5, okay, is basically saying that 2.718 to the power, to the 5th exponential, so 2.718 times 2.718 times 2.718, and so that's going to result in a really high number. So only thing you need to know is that this is going to take it and be able to increase it exponentially based on the number you have here. I personally have never used this one, so I haven't seen a whole lot of use, so hopefully that makes sense. All right, so we went through the first, looks like 11 of the different options on here. The ones you're going to see people use the most are add, subtract, multiply, divide. Don't use multiply, add very often, but sometimes that can be useful. Power is used on a regular basis, but the rest of these, logarithm, square root, inverse square root, exponent, aren't used very often. Absolute can be useful because if you're doing something that's going to result in a negative number based on a pattern or something you're doing, but you still want it to show, you could use absolute. That way it's still going to create a positive number at the end. So hopefully that helps. It's a lot of different information for one node, and this is only part 1, so we'll go through the next stuff in the next video. Make sure you like, share, follow, and stay tuned for my next one.